This demonstration shows a Latin rectangle extension problem. Okay, so we start with this 4x5 rectangle we've got here with entries in the range 1 up to 7, and we want to extend it to be a 7x7 Latin square. The standard theorem says that this is going to be possible provided that every entry in the range 1 to 7 has an excess that's greater than or equal to 0. Okay, so remember, the definition of the excess is, well, firstly we define the multiplicity Lk as just the number of instances of k. So here we look at 1. K equals 1. There are 3 1s, so L is 1. L of 1 is 3. There are 2 3s, so L of 3 is 2. There are 4 5s, so L of 5 is going to be 4. And then the excess, remember, excess is given by the multiplicity plus n minus p minus q. In this case, n is 7 because we've got stuff in the range 1 up to 7. P is 4 because we've got 4 rows. Q is 5 because we've got 5 columns. So if we do n minus p minus q, that's minus 2. So the excess is always just 2 less than the multiplicity. So going back to here, the multiplicity was 3, the excess is 1. Multiplicity was 2, the excess is 0. Multiplicity 2, excess is 0 again. Over here, the multiplicity 4, the excess is 2. But the key point is just that all the excesses are greater than or equal to 0. And so the general theorem tells us that it is going to be possible to extend this rectangle to a 7x7 Latin square. So we're going to do this. We're going to start by just adding new rows until we've got 7 rows, and then we'll add 2 new columns. Okay, so we want to add 1 more row here, and so in this box we have to we're not allowed to add 1 4 5 6 because we've got those already in this column, so the possibilities are 2 3 and 7. Here we've already used 4 5 6 7, so the possibilities here are 1 2 3. Here we've used 1 2 3 5, possibilities of 4 6 7, and so on. But the key part of the method, though, is that we have to make sure that everything that already has an excess of 0, that's the 2, 3, and 7, we need to make sure that the 2, 3, and 7, they all appear in the new row, because otherwise their excesses will drop to be negative. Okay, so let's start trying to fill in this new row. So we maybe take a 2 here, and 1 here, and then maybe put a 7 in here. But if we do that, we get stuck, right? There's no possibility. The 1, 2, and 7 here have all been excluded. They've all used already, so that doesn't work. Okay, so we have to backtrack a bit and change what we did here. We put a 6 in here, say. Then we can put in a 7 there, and then we can maybe put in a 4 here. Okay, but the problem with this is that now we failed to put in a 3. Okay, 3 had an excess of 0 before, and the excess drops by 1 when we add a new row. It would go up by 1 as well if we had a 3 somewhere in this new row, but we didn't put a 3 in this new row, so the excess has dropped by 1. It's now equal to minus 1, and that means it's not possible to continue the extension. So we're going to have to change that a bit. So instead of here, we do maybe so we do 2 1 4 here, and then put in a 7 here and a 3, 7 here and a 3 there. Okay, so now we've completed this new row, and we've and the critical things that we had before, 2 3 and 7, we've got a 2, we've got a 3, we've got a 7. So the excess for 2 3 and 7 doesn't drop; it still stays at 0. Yeah, and we also put in a 1 and a 4, so the excess for 1 and 4 doesn't change either. It stays at 1. But the things that we didn't put in here, we didn't put in a 5 or a 6, so the excess for 5 drops from 2 to 1. Excess for 6 drops from 2 to 1, but that's okay because it's still positive. Okay, so this new row is good. So now we need to add in another row. Okay, so before we had 2, 3, and 7 in here, and we chose to use the 2, so the 3 and the 7 are still okay, and we moved them down. Before we had a 1, 2, 3 here, we chose to use the 1, the 2 and the 3 are still okay, so they moved down into the next row. Okay. So now, again, we start trying to fill in this row. Maybe we put a 3 here and a 7 here. Okay, but If we do that, we get stuck. There's no options for what we do here. So it's not good to do the 3 and the 7. So let's start again. Maybe we put a 3 here, a 2 here. I choose a 6, a 1, and a 4. Now we've completed this new row, but again we've run into trouble. We didn't put in a 7 in this new row, so the excess has dropped from 0 to -1. We've got a negative excess, and that means it's not going to be possible to continue the extension. So we need a 7. So let's actually put the 7 in here. We do 3, 2, 7, or 1, 4. So now we've added, before the critical indices were 2, 3, and 7. We've put in a 2, a 3, and a 7. So the excesses of 2, 3, and 7 stay the same at 0. We've got a couple more zeros here, and 1s there and there, but all the excesses are non-negative. Okay, so now we go to the next stage. Okay, so we've used the 3, so the 7 will move down. We use the 2, the 3 will move down. We've used the 7, the 6 will move down, and so on. And so we've got this here. So in principle, we need to sort of choose from these possibilities for the last row, but there's no choice to be had, because there is only one possibility in each place. So in fact, we've got the full collection of 7 rows, and this is now a Latin rectangle of maximum possible height. Okay, you can check that this really is a Latin rectangle. In the first column, 1, 2, 3, 4, 5, 6, 7. Here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So got everything occurring precisely once in each column. And again, you can check that there are no repeats in any row. So now we've got a 7 by 5 Latin rectangle. And we just need to add 2 columns to it. Okay. And remember, we had this theorem that if you had a Latin rectangle of maximum height, it's always possible to extend it to a Latin square. We don't need to keep track of the excesses anymore. Okay, so we write in this column, we've written all the possibilities. So here we've used 1, 2, 3, 5, 6. So 4 and 7 still left over to go here. Here we've used 2, 4, 5, 6, 7. 1 and 3 are left over, and so on. In each of these boxes here, we've got 2 possibilities. Okay, so let's start trying to fill it in. Okay, we'll choose the 4 here. Okay, so notice then that if we go down, we choose the 4 here, so we can't do the 4 here. That means that there's the only possibility left in this row is the 1, so we have to choose the 1 there. Okay, now we've used the 1 here, so the only possibility left over in this row is 3, so we have to use the 3 here. Okay, and then we go down to here. Okay, we've used the 3, only the 2's left over, so we have to do the 2. And now here we've used the 2, only the 7's left over, we have to use the 7. So we've filled in now 5 of these boxes, and we made a choice at the first stage, and then the rest of them we didn't have any choice. But now we have some choice again. We can either do the 5 here and the 6 there, or the 5 here and the 6 there. Let's do 5 here and 6 there. Okay, so now we've completed the whole of this column 6, 4, 3, 7, 2, 5, 6, 4, 1. And again, so we've used the 4, we haven't used the 7, so the 7 can move into this slot. You've used the 3, we haven't used the 1, so the 1 can move into that slot. So we get this picture here. And again, in principle, we should make choices for the last column, but there's only one choice in each place. So we just use the only thing we can use. And now we've got a 7 by 7 Latin square.